Okay, so now we get to our circle problem. And the first thing we're going to do, sorry, I should actually back up. If we want to see if there are the same number of lines or more lines in one segment, we need to be able to put them in a one-to-one. We try to put them in a one-to-one correspondence. So can we match the lines passing through the circle with a line that's outside of the circle? And if we can do that, then we could say, hey, that's the same number. Because remember, just saying it's the same, they're both infinite, actually doesn't work. Remember, there were more real numbers than there were integers, even though they're both infinite.
I wonder if there's more infinities than real numbers.
There are actually, I think, are more infinities. You just keep climbing up the infinities. And I don't know if it ever ends. Pretty crazy. It's a neat thing to study. I don't actually know a lot about it, but I know enough to be dangerous.
Well, there's infinitely many points on this circle. You can when a line passes through the circle, it touches exactly 2 points.
Yeah. So it's tricky to even know where to start on here, but I'm going to start with an easy problem.
Yeah.
Okay? I'm just going to look at lines in the plane that come over here vertically and come through the circle here vertically, but on this half of the circle. Okay?
Wow.
So there's something very surprising that happens here. Okay? There's a way we can match up, we can identify each of these lines by where it crosses the axis, right?
Yeah. So each line becomes a point on the axis.
Each line actually becomes a point on the axis, these vertical lines.
Wow.
With lines that are not vertical, it's going to be a little harder.
Yeah.
But with the vertical lines, we can identify each line with a point on the axis. So the vertical line that crosses through this point is different than the vertical line that crosses through this point, and different than the vertical line that crosses through that point, right?
Yeah. This means there's only one that actually passes through the circle.
Right. Well, there's only one that touches it exactly.
Yeah.
But we're going to ignore those for now, because you said passing through and not passing through, right?
Yeah.
The one that just touches it, does it pass through or does it not pass through?
Both.
So we'll ignore that one for now. But that's only one line anyway, so it shouldn't make a difference in infinity, right?
Yeah.
Okay, so let's say our circle has a radius 1, and I want to find a way to identify the points in between 0 and 1, bigger than 0 but less than 1, with the points bigger than 1 but less than infinity. How are we going to do that? Like, where could I make the point 1/2 go to over here? Where could I make the point 1/3 go to over here?
Well, or you can make it go to 2, maybe.
Okay.
And a third go to 3.
A third go to 3.
And a fourth, and it would keep going a fourth.
Take the reciprocal.
A fourth would go to 4. Where would something like 3/4 go to?
Well, 4/3.
Is that bigger than 1?
Yeah.
Yeah. Does each point over here go to a unique point over here when I take the reciprocal?
Yeah.
Yeah.
Does it go back when I take the reciprocal again?
Yeah.
Yeah.
Hey, wait a minute. And do I get all the points? How do I get a point that's super, super, super large far over here?
You make one that's super, super, super small here.
Like 1/1,000,000th goes to,
1,000,000,000.
and 1/1,000,000,000th goes to,
A billion.
and 1/Gram's number goes to.
Graham's number.
Whoa, wait a minute. So we just showed that there's the same number of points from 0 to 1 as there are from 1 to infinity.
What?
Whoa.
What? Because we can put them in a 1-to-1 correspondence, right?
Yeah.
But we also showed there's the same number of vertical lines in between 0 and 1 as there are between 1 and infinity.
Whoa.
Because remember, each vertical line we could identify with a single point, right?
Yeah.
Okay. So we're almost there. Now we just have to figure out how to deal with non-vertical lines. All right, ready to talk about that?
Yeah.